Hello, my lovely students. So, desperate times call for desperate measures. And so, because of that, although I would really like to present this personally in class, I'm going to make you guys a set of screencasts to help you prepare for exam. And it is new work, so we're going to use the screencast in addition to Blackboard to discuss the work. So let's get started. The most important work that I want you to cover for exam that I haven't yet covered in class itself is regression and correlation, or simple regression and correlation. Now, there were two words that I just mentioned now. The one was regression and the other one was correlation. But I'll discuss them step by step. I'll start with regression or regression analysis. Now, the definition in these notes says regression analysis enables us to develop a model to predict values of a numerical variable. So this variable can be measured in terms of numbers based on in relationship with, in other words, the value of other variable. And so what regression really does is it tells us about the relationship between two variables. And the one variable that we wish to predict, and predict is we want to make a inference, we want to be able to project what's going to happen to this variable. That one is called the dependent variable. And the other variable that we use, so we use information that we obtain from another variable, that one is called the independent variable. Now, the best thing for me to try and explain this, or to try and explain that, is to use an example. If you consider that you are a student and you need to write exams, a variable that I can think about in the context that you are sitting in is the time that you spend with your work and your results. The time that you spend with your results is a variable and your results is another variable, and we can say that one variable depends on the other variable. And in that example, the time that you spend on your work is independent, but your results, that variable depends on the amount of time. Both of those variables can be measured. So if we have a look there, I also just want to point out it's based on a numerical variable. Both of them are numerical. So a little bit of theory that we consider is, why do we use regression analysis? Well, we want, besides making a prediction of what's going to happen to the dependent variable, regression analysis allows us to identify a type of mathematical relationship that exists between the two. So in terms of mathematics, we can actually formulate how the relationship works between these two variables. We can quantify the effect of the change that's going to happen in the one variable, which is going to affect the other variable. And finally, it also helps us to identify or be able to pick up unusual observations. But at the end of the day, what we're going to use it for is to make predictions or to build models. And when you're working in industry, building models is very important. So you're going to build a model that's going to help you predict what is going to happen to the independent variable if you manipulate the dependent variable. So as with everything that we know in stats, we're going to collect the sample. And when we collect the sample, we will find for each one of the little observations in our sample group, we will have two numerical values. We'll have one numerical value for the independent variable, which we refer to as x, and for the same observation in that sample group, we will also have a numerical value for the dependent variable, which is known as y. And the example that I used earlier on was study times and grades, where grades is the dependent variable. If I want to manipulate or change my grades, then I will try and see if I can change my independent variable to see if I can adjust my grades. But to be able to do that, I need to understand the relationship between the two of them. So that is an illustration of how the one depends on the other one. When I make a change in the amount in the independent variable, I expect to see a change, either greater or lesser, but I expect to see a change in the dependent variable if there is a regression relationship between the two of them. So I start by drawing a scatter plot. I don't know if you have done this before, but a scatter plot is where each observation is assigned 2 scores on a graph. Yes, we have done this. We did this in descriptive stats. And so 1 score for the independent variable is given on the x-axis and 1 score is given on the y-axis. And so the regression line, which is also known as the line of least misfit, is placed on the scatter plot so that I can, so in a way that it can't be improved. So the line that best describes the relationship between the two of them is also known as the line of best fit, which the other way, stating it the other way around, is also the line of least misfit. But we can't use a graph to work this out. We do it analytically. But to explain what it is that I was trying to put into words, and maybe my words wasn't so clear. So if these are my xi, I will have, we all know this and we know this from descriptive stats, I will have my x-axis or independent variable, or my x-axis, will be down at the bottom here. And my y-axis or my dependent variable is the vertical one. The x-axis or the independent one is the horizontal one. Independent, and this is just my dependent axis. And so if I have a sample, let's say I take a sample, and I'm going to use a silly example, 5 students. Palesa and Miguel and Ernest and Zabello, and who else is there? Jason. And each of them will have a value, a numerical value for the amount of study time that they spend, and also they will have a numerical value for the amount of marks that they get. And so for each one of these 5 students, I will place a dot on my scatter plot. So that's my 5 students. Now, I want you to think about this for a second, for a few seconds. What is the line? If I was to draw a line to try and describe the relationship between, what was this, marks and study time, what would be the best line? Would it be that line to describe the relationship between study time and marks? Or would it be that line? Or maybe even that line? Or would it be, let's see, maybe even this line? All of those lines look fairly familiar. That's right. If I take away any one of those lines, or if I take away some of those lines, you'd be forgiven to think that is maybe the line, or maybe that one. So what we're going to do and what regression does is it calculates the distance, the squared distance between each one of our sample points and between the line. And it works out the the distance, it sums up that distances, and the least amount of distance, square distance between each one of the sample points, and the best line is our regression line. And that's what I meant when I spoke earlier on, and I told you about the line of least misfit, but it's also known as the line of best fit. And it is, if I look at that picture, this picture gives me an idea of what it is that I'm trying to accomplish by finding out what that line is. So yes, this is a picture in the notes. How do I represent that line? I represent that line. I'm not going to do a scatter plot each time that I want to work out the regression relationship between two variables. It's impossible. I'm not going to do a scatter plot to do that and try and measure it. I'm going to use this mathematical formula where y is the intercept. It's also denoted by beta 0. It is the intercept for the population. Now, what do I mean by intercept? Let's look back again. My intercept is that point over there. Well, let's go even further up. My intercept is where my line is going to cross my y-axis. So if that is my line, this over here is my intercept, or B0. Okay. And then B1 is the slope of my population. Now, what do I mean by slope? Well, my slope means the amount. When I look at this line, can you see that this line is sloping? So what I mean by that is every time that my x value changes, I expect to see a corresponding change in y. So for every 1 unit that my x-axis goes up or down, so every 1 unit of change, for every 1 unit of change that takes place in this x-axis, I expect to see some sort of change in the y value. And that is what my slope is. So every 1 unit up or down that my x-axis move, for 1 unit of change that happens in my independent variable, what is going to happen in my dependent variable? Now, guys, these videos are only 15 minutes long, so I'm going to stop here and I will start the next video on a new screencast. See you later.